All right, so here we have, let's see if I can do this. There we go. We have three types of hydrocarbons. Remember, hydrocarbons are organic compounds. Last unit we remembered it's all about carbon, or last entry, all about carbon. And we have three types of hydrocarbons. We have alkanes, alkenes, and alkynes. So take a moment to pause the video and write down alkynes, alkenes, and alkanes. For each of these, you can also write down our general formulas, which for an alkane, we're going to make them with 5 carbons, it will be C5H12. For an alkene, it will be C5H10. Notice it just went down by 2 hydrogens, and C5H8. Okay, so take a moment, pause the video, and write down that information. You can also write down the general formulas, which for alkanes is CN H2N plus 2, and the N is just the number of carbons. So if I have 5 carbons, then it'd be C5, and then 2 times 5 is 10, plus 2 gives me 12 hydrogens. It's just a way for us to predict how many hydrogens are in the formula. For alkenes, it's Cn and then H2N. I lost 2 hydrogens, so there's no plus 2. And then I lose 2 more hydrogens, so as you can imagine, it's going to be minus 2. Okay, so that's our information here as we go forth. So pause the video and make sure you write that down first. And then I'm going to move on. Okay, so alkanes, for each of these, we're going to start with just drawing 5 carbons out. Okay, 5 carbons out. Draw 5 carbons out. Okay, now that's because there's 5 carbons. Now what we need to know is that each line represents 1 bond, or the sharing of 1 covalent bond, or the sharing of 2 electrons. And carbon always forms 4 covalent bonds. 4 covalent bonds. So that means that each carbon needs a total of 4 lines coming off of it. And so if I look at this first carbon, it only has 1, so it needs 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay. And same thing here, I can do 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And you're going to notice pretty quickly that drawing them like this is kind of a pain in the butt, so there's a simpler way we'll learn afterwards. Now after that, each of these things that it's connected to is just hydrogens. And that's what's going on here. So for my first one, there's 5 carbons. Each carbon has 4 lines coming off of it for a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. And that's my compound. And now the name is based off of what it is. So it's an alkane, so it's ANE. And then you say how many carbons are in it, which 5, so it'd be pentane. We'll learn more about this today. Okay. Now, this is an alkene, so we're going to have to make a change here. So its ending, instead of ANE, is going to be ENE, but there's still 5 carbons, so it's going to be pentene. And as you can imagine, there's 5 carbons here, pent, and it's a triple bond, so YNE. Now, every carbon needs 4 lines coming off of it. An alkene means there's a double bond, so somewhere, and it can be in any different location, there's going to be a double bond. So you have it written like this. Let's just say I put a double bond in right here. That means off this first carbon right here, there's 1, 2, 3, 4, 5 lines coming off of it. If you count it, 1, 2, 3, 4, 5. Okay? And now the nice part about that is it removes 2 hydrogens. So what has to happen is in order for that to happen, I have to remove 2 hydrogens. And you can imagine that if I were to put a triple bond here, let's do it that way, make it a little bit neater. I'm just going to redraw it. Triple bond. What's going to happen is I have to remove, so there's only 4 total lines off of each hydrogen carbon. So this one has 1, 2, 3, 4, 5, 6. So I got to remove that one and that one. And then I have 4 coming off of this carbon if I were to count it. 1, 2, 3, 4. Okay? And then off of this one, I have 1, 2, 3, 4, 5, 6. So I have to remove 3 lines, or sorry, a couple lines here. So I have 1, 2, 3, 4, and that's it. I just have 1 line. So what happens in these types of compounds, in these hydrocarbons, is that you can have different bond types. And that means each of these leftover pieces is just a simple hydrogen being added in. What's the point of this? Remember, hydrocarbons are the basis for all organic compounds, from anything from a plastic to medicine that you take to food that you eat. A lot of it is basic hydrocarbons. Now you might be saying, okay, that's really a long period of time and so forth, but how do I draw it in a simpler way so I don't have to draw these hydrogens in? And what you can do is draw lines. So if I were to draw a line like this, what it tells you, there's a carbon here and a carbon here. So there'd be 2 carbons. So what I want to do is draw one with 5 carbons. So there's 1, 2, 3, 4, 5. There'd be a carbon here, 1, 2, 3, 4, and 5, and that's it. And there's 5 carbons. Numbering them 1, 2, 3, 4, 5. And there's single lines, so you see a single bond between each of these things. Okay, now you'd see in pentene, I have 1, 2, 3, 4, 5 again, except there's a double bond between my first and my second carbon. And these are called line structures. Then pentyne, again, I have 5 carbons, but there's going to be a triple bond between the first and the second carbon. Now, the other thing you have to do with names is say where it goes. So it'd be 1 pentene or 1 pentyne. Okay, but really, let's just pause the video for a second. And there's a lot of information here that I know is mildly confusing, which is fine. Take a second and just go through and identify each of these compounds. So this compound right here, this one right here, this one right here. Okay, those two are the same one, this one, and this one, as alkanes, alkenes, or alkynes based off of the carbons in there. And then if you can, count and number the carbons, because that's a big skill. So let's pause the video and do that. It'll look like this. So for this one, there's 1, 2, 3, 4 carbons. And that tells me there's also a triple bond, so it's an alkyne. So that's all you have to do for each of these. This first one, there's 1, 2, 3, 4 carbons, but there's only single bonds, so that means it's an alkane. Okay, pause the video and try those last 4, and then I'll do them. Okay, so this one, there's 1, 2, 3, 4 carbons as well. It's a double bond, so that is an alkene. ENE means double bond. So here I got 1, 2, 3, 4 carbons. It's an alkene again. Here there's 1, 2, 3, 4, 5 carbons. A lot of people will get that one wrong. They'll say there's 4 carbons. The reason why is because this triple bond is between 2 carbons. So there has to be a carbon there and there. The reason why that's significant is because a lot of times with these triple bonds, they can't rotate as much. In this one, counting might be a little confusing. That's okay. It's an alkane. There's all single bonds, and there's 1, 2, 3, 4, 5, 6, 7, 8 carbons in the longest chain. There's also an additional 9th and 10th one out here, but we don't count those in the longest chain. Not the most important thing in the world. Okay, so you might be thinking, all right, how do we name these things? And that's the biggest lesson from today. So the first thing you do is you count the number of carbons. This is the prefix that I use from this table right here. So determine if it's an alkene or an alkane, alkene, or alkyne. If it's an alkane, it ends with ane. If it's an alkene, it ends with ene. If it's an alkyne, it ends with yne. Okay? So let's say I had 2 compounds. Let's try 1, 2, 3, 4, 5, 6. Actually, I take it back. Let's do 4 carbons. Let's do 4. That'll be the easiest. 1, 2, 3, 4. 1, 2, 3, 4. Or I'm going to do 1, 2, 3, 4. And then here, 1, 2, 3, 4. 1, 2, 3, 4. Or. And then this one, I'm going to put a double bond right here. Ooh, that turned out really bad. Put a double bond right here. And this one, I'm going to put a double bond right here. Okay. This one, I'm going to put a triple bond right here. Then I'm going to put a triple bond right here. And we're going to name these things. Okay, so all of these, the first thing you do is you count the number of carbons. 1, 2, 3, 4, and you pick the prefix. 4 is bute over here. So this one's bute, and then it's all single bonds, so it's just ane, butane. Okay, both of these guys are going to be bute because there's 4 carbons. 1, 2, 3, 4. 1, 2, 3, 4. So they're going to be butene, but they're clearly not the same compound because there's a double bond here and there's a double bond there. Okay, so what you do is you put a number in front that tells you the lowest number that the double bond is on. So here it could be 1 or 2. I'm going to say 1 because it's the lowest number. Here it could be 2 or 3. I'm going to put 2 because it's the lowest number. Same thing with the triple bond. See if you can name them the same way. And this is the last part. Name the parent chain of the double triple bonds between the lowest possible numbers. Okay. So this one I'm going to put 1 because that's the lowest number. 4 carbons is but, YNE, because it's a triple bond. And then here you're probably thinking it's 3 butene, right? The lowest possible number. But what about if I numbered it from the opposite direction? What if I numbered it 1, 2, 3, 4? Does that matter? Yeah, because actually, if you were to just take this compound and turn it 180 degrees, so rotate it, oops, I didn't want to do that. Take it and rotate it 180 degrees, it would look exactly like this compound. So we'd have 2 names for the same compound. So the most important thing that you can do is always remember to try numbering from both directions, because this compound, instead of being 3 butene, is actually 1 butene. Okay. So let's look at the example. There's 2 ways to draw 1 hexene. Hex means 6 carbons, so I'm going to go up here. 6 is hex. So I'm going to draw 1, 2, 3, 4, 5, 6, and double check 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And if it's helpful, go ahead and number the carbons every time you do it. ENE means there's a double bond. 1 tells me it's between 1 and 2. 2 tells me it's between 2 and 3. Okay, the lowest possible number is 2. The lowest possible number is 1. So that's what those would look like. You could also draw it the opposite direction. So 1, 2, 3, 4, 5, 6. And that would be the same compound. Or this would be the same compound, because the double bond is in the same spot. It's just flip-flopped. So what I want you to do is just try naming a few of these. Pause the video and we'll go over them. So what you have to do is you have to count the carbons. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5. And that tells you your prefix. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay. So make sure you get those numbers down. What you do is you count the carbons. So the prefix for 3 is prop. So this is prop. It's all single bonds, so my ending is ANE, and that's based off of this right up here. Alkane, all single bonds, ANE. So right now you could go through and put the ending. Well, this one's a double bond, so it's ENE. Triple bond, so YNE. Single bonds, so it's ANE. Single bonds, so ANE. Double bond, so ENE. Triple bond, so YNE. Single bond, so ANE. And then you just add the appropriate prefix. Here, 4 is but. And then what's the lowest number the double bond on? Is 1. So it's 1 butene. Here it's 1, and then 3 carbons is prop, so 1 propine. Here it's 2, and 5 carbons is pentene. Here it's 1 and propine. It's actually the same compound as this one, if you didn't notice. And 4 is butane. Okay. So when we draw them, what you do is you figure out the number of carbons, draw out the parent chain, and then add in a double or triple bond if needed. Okay. So there's obviously more complex compounds we could get to, but we're just going to do simple ones. So pentane is, this should be pent. Pent means 5 carbons. Okay, so for this one, there's going to be 5 carbons. 1, 2, 3, 4, 5. And then you got to double check, because 1, 2, 3, 4, 5, 6. Oops, I overdrew it. So I'm going to back it up. I got to redraw. 1, 2, 3, 4, 5. Just be careful to make sure you count. So 1, 2, 3, 4, 5. Good. And then it's ANE, so it's all single bonds, so it's good the way it is. So this one's going to be pent as well. And then 2 tells me there's a bond between 2 and 3. So I go to my second carbon and draw in a double bond. 1, 2, 3, 4, 5, 6, 7, 8. Double check. 1, 2, 3, 4, 5, 6, 7, 8. Great. I go to my 1, 2, third carbon. In between 3 and 4 is a YNE triple bond. Okay. So why don't you just roll through this, pause and roll through it, and then I'm going to draw them out here really quickly. Okay, so hept means 7. So 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, there's a YNE triple bond here. Pentane is 5. 1, 2, 3, 4, 5. ANE means all single bonds, so we're good to go. Hex means 6. So 1, 2, 3, 4, 5, 6. 1, 2, there's a double bond between 2 and 3. Now you might ask, does it matter whether I start drawing up or down? So instead of going up on that one, could I go 1, 2, 3, 4, 5, 6? And then 1, 2, 3, 4, 5, 6. Good. Draw a double bond between 2 and 3. No, those are the same thing. Because all you'd have to do is take your paper and flip it from front to back, and it would be the same orientation. Okay, so bute is 4. That's actually 5. My bad. 1, 2, 3, 4. All single bonds, so we're good to go. Dec is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then go to your fifth one. 1, 2, 3, 4, 5. In between 5 and 6, I have an ENE double bond. Octane is 8. 1, 2, 3, 4, 5, 6, 7, 8. All single bonds, so we're good to go. Decyne, same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops. Go to my first, second, third carbon. In between 3 and 4, I have a YNE triple bond. Nonene is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Go to my second carbon, draw an ENE double bond. Ooh, that was terrible double bond. Even worse. There we go. Great. Okay, so a quick review. How many bonds does carbon form? 4. What type? Covalent bonds. How can I describe alkanes? That's with this formula here. Alkenes is with this formula, and alkynes is with this formula. And that's it. We're good to go. Let me know if you have any questions.